Hello, CIS C157 students. Wanted to record another video tutorial going over the week 12 content and assignment that you'll be working on. So week 12 here is our first introduction to object-oriented programming, which is a different programming paradigm than we've been using historically up to this point in the class. And we're going to walk through an introduction of what object-oriented programming is, what benefits it offers, and then specifically how to work with classes and objects in Python. So in this tutorial, we're going to practice again some concepts that you will need for this module's assignment. We're not going to build the assignment that you have directly. Instead, we're going to use a programming example for creating a car class, like an automobile, in Python. So we'll practice classes, constructors, instance variables, class variables, and then creating objects and formatting output, all of the different techniques and concepts you'll need to understand for your individual week 12 assignments. So I'm in Visual Studio Code here, and you'll see that I made just a new empty Python file called car demo. And this is where we're going to write our entire program here. So in object-oriented programming, we are going to create a class that represents an automobile or a car specifically. And then we're going to create objects or individual instances of that car class, each with its own information, such as make, model, color, mileage, some common things that you'll want to have associated with a car. Before we write much code, though, we're going to talk more about objects specifically. And in this example, the object is a car itself. And so if I create three car objects, each one should have its own details. So in order to create any objects, we need to define a parent class first. And you can think about a class like a blueprint or a design spec for the individual cars that we're going to create later on. And in Python and many programming languages, the keyword that we're going to use to define this blueprint is called a class. And so I will start off first in Python, just at the top of the file here, by using the keyword class. And then I'm going to give the class a name, and my class is going to be called car. And then we'll do a colon and move down to define some variables on this class. So inside the class, I'm going to create two class level variables. And these variables are going to be total cars, which I will set to 0, and then total miles, which I will also set to 0. Total cars will count how many car objects have been created later in our program, and total miles will keep track of the combined mileage for all the cars that we create later on. Again, these are class variables because they belong to the car class as a whole, and they're going to be shared across all of the objects that we create from this class. The next thing that we're going to do in our class is we're going to define a constructor method. Now, in all programming languages, classes have something that are called constructors, and a constructor is essentially code that runs every time we create an object based off of this class. In Python, we define the instructor method with a function called init. So we'll write def, and then it's two underscores, init, two underscores, and then we're going to, that's the name of our function, so it's dunder init is the technical name for this. A dunder method in Python is just one that starts and ends with these two underscores. You might have seen the main that you've used elsewhere in your programs here. And so this is a constructor in Python. And into the constructor, we want to pass some parameters here. We're going to start off first with the self parameter. The word self refers to the specific object being created when we create some later on. Then we're going to pass in some additional variables that we want our car to have here. So we'll do a make, the make of the car. We'll do the model. We'll do color. And we'll do the mileage or the miles that this car has when we create it. And then we'll do a colon because this is a function. And we're going to go down and basically assign these parameters here. So for this first one, we're going to use that keyword self, which again refers to the individual, the specific object that we create later on. And we're going to just say that the self.make equals make, which is the parameter we're passing in. And we're going to use this same syntax or this same style here for all of the parameters, just assigning them to self. So self.model is model, self.color equals color, and self.miles equals miles. Right? So when we create an object, an instance of this class, we're always going to pass in the make, the model, the color, and the miles. And then we're going to assign to that individual car that we're making using this self keyword, the values that we pass in, basically. That's all that this constructor is doing here. So if I create a Toyota, for example, that individual Toyota object will get its own make, model, color, and mileage. If I create a Honda, that object will get separate values that'll be applied to it. And so all of these are known as instance variables because each individual car object has its own copy of these specific variables. Whereas above, these are class variables that are shared amongst all of the cars that we create, okay? These are limited to individual cars. These apply to all cars. Main difference between class and instance variables. All right, since we have these shared variables that we want to be updated as we create cars here, we're going to need to do some more work in the constructor to update these class level variables. So we said that total cars is going to track the total number of cars that we create in our program. So because of that, the constructor is a great place to update this logic because the constructor is automatically called anytime we create a car. So we'll just go down a couple of lines here, and I want to essentially add to this constructor, hey constructor, when a car is made and when you're automatically called, please update the class variables for us. So total cars, and we're going to specify the class variable by naming the class first and then doing a period, and then we're going to write the name of the class variable, so total cars. And we can do plus equals 1. Again, this is just shorthand for car.total cars equals car.total cars plus 1. Same code. This is just a shorthand in Python, so we don't have to, write car.total cars twice, but we're essentially just incrementing the current value by 1, adding 1 to it. Okay, so that makes sense for that. When we make a car, we want to add 1 to this variable up here. The next one is to update the mileage, right? Based on the current mileage of this car, because this variable is tracking like the total mileage across all the cars that we make. We'll use the same syntax, so I'll call the class with car, but this time I'm going to do total miles plus equals. Now, what do we want to add to the total miles? We want to add the current value of miles here that we're passing in the parameter. So I'll do miles. Right, so again, these two pieces of code, this one increments our car counter, our total cars class variable by 1. And then this one adds whatever mileage this individual car has when we make it. It adds that mileage to our total miles class variable so we can track the total miles. And again, most important part here is that we are prepending these class variables with the car word, the name of our class itself, to be explicit that we are targeting class level variables. Where again, when we're dealing with instance variables, we use the self keyword, which automatically refers to the current object being created. And that should be it for our constructor method. So we're kind of done with the class now. This is our entire car class as it stands here. So we're defining total cars and total miles, which are automatically tracked for us. And then individual cars, when we make them, we're going to have to pass in the make, model, color, and miles. We never pass in self because that is just referring to the object itself when we create it. But we pass in all the other parameters, and this logic automatically takes place for us. So now we're at the point where we can kind of move to the main program logic. And this is where we're going to start creating cars. Again, we just defined a blueprint here. This is what a car looks like. This is what happens when we create a car, but we haven't actually made any cars yet. Now we get to make some of our cars here, and your assignment is going to ask you to do something similar. So for us, let's go ahead and create 3 different car objects. And so I'll write this out and then we'll talk through what's going on here. I'm just going to call my cars car1, and I'm going to set it equal to car, the name of the class, and then I'm going to type in the make, model, color, and miles. So let's do Toyota. We'll do Corolla for the model. Let's say that this one is blue, and we'll say that it has 42,000 miles. Then I'll do car 2, same format. This time it's a Honda Civic. Say this one is silver, and it has 36,000 miles. And finally, car 3 will be a Ford Mustang that is red with 18,000 miles. And we are done creating our objects here. So all three objects use the same car class that we defined above, but each object stores different data in it. Also, each time we create this car, the constructor, our def init, is going to run and it's going to update our shared class variables. Now that we have created our cars, let's print some information about these cars so we can see what they look like and make sure everything is working correctly. So I'll just kind of format this as car inventory, and we'll just start printing some info here. So I'm going to print for each object. We can do this in a loop. So for car in cars, actually, I'm going to do this a different way. It's not the best way to do it. Yeah, rather than walking through a for loop right now, I think I'm just going to print these individually because I don't want to get into the list comprehension or putting these in a list to loop over them at this point. Just not relevant to the current assignment. And I think we'll focus on just looking at the details now, and then maybe we can come back to looping over the printing of these. So I'm going to start with a print statement, and we'll just do car1 first. And let's print out the color, and then we will print the make, the model, and then the miles. And let's just see what that looks like. We'll run it first to make sure that it's the proper format before we do the same for the rest of them. So I'll run this, and then we can see the output here. We have blue Toyota Corolla, 42,000 miles. That looks decent to me. I'd like to capitalize the color too. Rather than going back and updating this part where I'm passing in the color, I'm just going to use a method called title here, which will automatically capitalize the first letter. So if I run it again, now you can see blue is just capitalized, so I don't have to rely on the user passing in kind of a capital color value when they create a car. We're explicitly saying, treat this as a title, so capitalize the first letter of it. And here's what the output looks like. So we get blue Toyota Corolla and then 42,000 miles. That looks good to me. I'm going to copy this line of code, and I'm going to paste it 2 more times, and then I'm just going to change car1 to car2 for all of them so that we're referencing our second car. And then I'm going to do the same for our third car here. All right. And the main takeaway here is to notice that I am accessing instance variables through each object using a period. So we call the individual object, and then if we want to access any of these instance variables like make, model, color, or miles, we do a dot or a period in the name of the instance variable, and that will pull it out of the object for us, right? All the values we passed in as parameters here. And that's how we access instance variables. So for example, car1.make, like you saw, this is going to look for the make, and it's going to pull out Toyota for us. And we already went over the dot title method, which just makes the color display with a capital letter. So now if I run this again, it should print out our full kind of car inventory here. So we can see everything looks good and we're getting the correct values. Okay, let's go ahead and take a look at some of the class variables or the class statistics that we're also going to want to print here. So I'll go down another couple of lines. We'll do a comment to say print car class statistics, right? Similar to what you're asked to do in your assignment when you're tracking some of the LLM prompts here. So what do we want to do? Well, I think one of the things we can do is since we're collecting the total miles for all of our cars, we can calculate maybe the average mile per car. So just the average number of miles we have here. So let's make a variable called average miles, and we will set that equal to, how would we find the average here? Well, the average is going to be the total miles divided by the number of cars that we have in our inventory, right? And fortunately, we are tracking both of those variables up here, so we can use those class variables. So we'll say average mile, we'll call the class itself and say dot total miles divided by the car dot total cars, okay? And this will automatically pull the right information, the total miles that we've been tracking and just divided by the total number of cars that we have created here. That's really the only variable we need. Now I'm just going to print a space between the end of our last output, and I will print kind of another header, inventory statistics, we'll call it. And then let's go ahead and just print some of these values here. So we'll do a print statement. I'll say total cars equals car dot total cars. Then I'll print total miles, and we'll set that equal to car dot total miles. And then we'll print the average that we calculated. So we'll print average miles per car, which will equal our average miles variable that we defined up above. And let's format this to one decimal place there. We don't need to go beyond that. All right. And so let's go ahead and run this now and see what our statistics look like that we've added here. So I'll run it again. All right. And so as you can see, we have the same car inventory. Down below now, we have the inventory statistics. We have our total cars, which is correct. At a glance, our total miles looks correct. And then our average miles also looks correct, 96,000 divided by 3. All right, and the benefit of this is that we can add more cars. So if I create a fourth car, update a fourth one here just to make the object, and then I'll go back and actually create it above. So now I'll do car 4 equals, we'll say, let's do another Ford Explorer. We'll say this one has 200,000 miles. If I run it again, we'll see that all the class gets updated for us, right? We don't have to track it separately. So now we have 4 total cars. Our total miles went way up, and our average miles obviously went way up too because we had 200,000 miles on this new Ford Explorer we made. So there's some of the time saving there, right? When we define these class variables that are automatically updated in the constructor for us, we don't have to individually calculate or keep track of the total miles, right? Or the total number of cars we're making. Any logic that we encode in a class like this is automatically handled for us so that the user can just create new cars or add new cars to our inventory, right? And all of the important statistics we want to track on the back end, we've kind of defined how that already works and it's handled automatically for us. So we can save a lot of time when we're working with classes and objects like this if we think up statistics that are important that we want to keep track of in our class variables. All right, so we looked at the output there. We understand, hopefully, the difference between the blueprint, which is the class itself, which is just defining what these objects will look like, versus creating individual cars or objects based on this blueprint. And then the other big takeaway is the difference between instance variables, which are unique and potentially different for every car that we make, versus class level variables, which apply and are shared amongst all of the cars that we're going to create here. And then we have our constructor method, which automatically runs when we create a car, right? So all of these variables get assigned. And right here, we are explicitly updating the class level variables automatically whenever we create a car, because this whole block of code runs every single time we call the car class and create a car. So just those basic concepts there and kind of the basic demo we put on here, you can start to brainstorm and think about how valuable this can be and how much logic you can add here to automatically handle things that are important to track, things that are important to update, or things that you want done when a user creates an object based off of a class. And at a core level, this is how we work with objects and classes in general in Python. And so for your assignment this week, it's important to ask yourself some questions as you're going through this to make sure you're understanding the basic concepts of object-oriented programming. You could ask yourself questions like, what does one object represent? What information belongs to each individual object? What information should be shared across the whole class? Where should the shared totals be updated? How can I use F strings to make the output clear and readable? You can see we've done that throughout. And if you can answer all of those questions as you're looking at your individual LLM prompt assignment, your program should function very similarly to this, right? There's no concepts that are in your assignment that we haven't covered here. You just might have to make some modifications to apply to your LLM prompt tracker class versus this car class here. All right. So I hope you have a good understanding of this. Object-oriented programming is a very popular and important paradigm to understand in programming. So make sure you have a good understanding at this level as you move on to your assignment next week in week 13. We're going to introduce some additional benefits and features of using classes and objects in Python, and it'll continue right where we left off here. All right. Thank you, everyone. I'm looking forward to seeing your LLM prompt tracking programs in action. Have a great weekend.